Okay, here I want to talk about a graph related to displacement for accelerated motion. Okay, if you recall it, I talked about the graph of velocity and acceleration for accelerated motion. So just for quick review here, graphs for accelerated motion. So you have these two graphs for velocity, but before velocity, I prefer to talk about the acceleration at first. So here, the vertical axis is A, or acceleration. The horizontal axis is T. And according to this course, the acceleration of your moving particle is constant value. I mean, you have always constant value for acceleration in this course. But in reality, it's possible to have variable acceleration, but this is not the scope of this course. So here, acceleration of your moving particle doesn't change. Therefore, you have a horizontal line here. A is constant. This is acceleration. Okay, the next graph is related to velocity, and I talked about the velocity before. If you remember, I prefer to make a copy and paste here. These are graphs for velocity, depending upon the type of velocity, maybe increasing velocity or decreasing velocity. And the next one is displacement. Okay, pay attention, please. That's something new. Okay, what is the equation of displacement for accelerated motion? If you remember, I proved this equation, and it's here. This one. This is equation of displacement, x equal to half a t squared plus v0 t. Consequently, let's look at this equation. So x equal to half a t squared plus v0 t. You know acceleration is constant value according to this course. V0, or initial velocity, is always constant value. Therefore, on the right side, you have a variable which is t, or time. This is your independent variable. And on the left side, you have dependent variable, that's x. So if you have this kind of equation, and independent variable is t squared here. Okay, in mathematics, if you have a t squared, at that moment, your graph is not a line. It is a curve. And this curve is called the parabola. Consequently, displacement of accelerated motion under constant acceleration is a parabola on the coordinate. Let's plot it. Consequently, you have this graph. Vertical axis is displacement X or D. Both of them are correct. Horizontal axis is T, and you don't have a line here. It's a curve like this. Look at it. It is called parabola. It is only for accelerated motion. Of course, graph of displacement for constant velocity is not a parabola. It's a line. If you remember, I discussed it before. Okay, therefore, you have this curve here. Now, let me have quick review. If you have acceleration, or if you have accelerated motion, the graph of acceleration versus time is here. It is horizontal line because it is constant. Therefore, this is your graph of acceleration. Graph of acceleration. If you have velocity, remember the equation of velocity. That's AT plus V0. And that's a line. Therefore, here, this is graph of velocity. If you have increasing velocity, you have ascending graph. And if you have decreasing velocity, you should have descending graph. And the graph of displacement, it's here. That's a curve. It is called parabola. Okay, perfect. Now, let me give you some examples regarding accelerated motion. Example. There is a particle. It has initial velocity V0. That's 4 meters per second. If acceleration of this part A, if acceleration of this particle is 2 meters per second square, what is the required time to reach velocity of 12 meters per second? In other words, if V is 12 meters per second for this particle, what is T value? This is part A. Part B. If A is 2, acceleration is 2 meters per second square. after 5 seconds, what is displacement traveled by this particle? This is part B. Okay, let's do it, part A. If you look at the part A and information of part A, you can figure out that you have acceleration, you have final velocity, that's 12, you have initial velocity, which is 4, and you need time value. Obviously, you need velocity equation here to find t. Therefore, use this equation for part A. V equal to AT plus V0. V is 12, A is 2 times t plus 4. Therefore, 2t equal to 8 and t equal to 8 over 2, which is 4 seconds. T is 4 seconds. Answer of part A. Let's switch to part B. So acceleration is 2. What is the displacement traveled by this particle after 5 seconds? Of course, you need x or displacement equation. X equal to half AT square plus V0t. This half, A is 2, T is part B, it is 5 seconds. 5 square plus 4 times 5. You know that 5 square is 25. Therefore, it is 2 over 2 is 1. Therefore, it is 25 plus 20. The second part is 20. 4 times 5 is 20 here. Therefore, that's 45. X is 45 meters. Answer of part B. Okay. Next example. There's a particle here. It's going to the right, which is rectilinear motion. Initial velocity of this particle is 10 meters per second. If acceleration is 1.5 meter per second square, if this particle travels, for example, 30 meters, what is the velocity of this particle? What is V? Okay, what's your idea in this regard? What's your idea to solve this problem? If you look at this problem, you have acceleration and you need velocity, and you have displacement traveled by the particle, 30 meters, but you don't have t quantity. You don't have time quantity here. And I told you, if you don't have any information regarding time quantity, you should use equation number 3. And I proved it before. It's here. Use this equation to solve this problem. Very important. Therefore, I repeat it. If you don't have any information about time quantity and you need velocity, apply this equation. Equation number 3. So V square minus V0 square equal to 2AX. V square, we don't know. V0, that's 10. Therefore, that's 10 square equal to 2 times 1.5 times 30. V square minus 100 equal to that's 2 times 1.53. Right side is 90. Therefore, move 100 to the right side. It is Vs squared equal to 190. So V squared is not 190. What is V? You have to take square root. V is square root 190. Therefore, V is 13.78 meter per second. Answer of the problem. Thank you.